Video we will show that Fisher and the inverse hyperbolic tangent functions are the same. So this is good for values between -1 and +1. So we generate the data set of Fisher, which is RA formula, Fisher of the x values. And we will regress this. Insert chart, and we'll show the trend line equation polynomial to the power to the third degree. So here's the polynomial and the r squared. So it's negative 1.49 times 10 to the minus 17, can be rounded up as 0. 0.359x minus 1.73 times 10 to the minus 17, which is rounded up as 0, plus 1.97x cubed. So we will regress this using LINEST. We'll calculate the coefficient using LINEST. So to calculate this coefficient using LINEST, we have to fill in the x to the 0 column, x column, x squared column, and the x cubed column. So we begin with the x to the 0 column, which is RA formula of the x values raised to the power 0. So, and we'll copy it to the rest of the cell by locking the reference. We lock our reference. Now we copy it. So the x column will be this column, which matches to this column, x. Then the x squared column will be this column. And the x cubed column will be this column. This is the x cubed column. Now we can enter the LINEST. LINEST, data y, and data x. So RB0 is 1.49 times 10 to the minus 17. But this is actually 0. RB1 is 0.359, which is 0.359. RB2 is 0. Here it is negative 1.73 times 10 to the minus 17, which is very small and can be rounded up as 0. And our B3 is 1.971, which is also 1.97 in the chart. Then we can get the estimated y and mult of the 1 comma x matrix and the coefficients. Here's the estimated y from the regression. We'll insert this to the chart. Edit chart, add series, choose the range, and we'll choose this range. And we'll show the equation as well. Trend line, same, polynomial to the power 3. And we will show the equation as label and also show the r squared. The r squared is 1 because it is regress against itself. So we will get the same result. This is the one in red, the estimated y, and the ones in blue is the Fisher function. We can get the same result using the inverse hyperbolic tangent, which is RA formula, ATAN h of the x values, and the values are exactly the same. We can use LINEST, data y, and data x. the coefficients are also exactly the same. So this shows that Fisher function, the result of the Fisher function is the same as the result of inverse hyperbolic tangent.